Okay, welcome to the light-hearted uh, lunch break talk. I work with Aton. We are a great place to work, a benefit corporation, a big corp, just a couple of hours from here. And I'm Michele Mauro. I'm senior developer there. I usually do backend work in Java and Kotlin. And I will talk to you today about the Amsterdam Plot. And I need a quick disclaimer before starting. This talk is about history, the kind of history that you shouldn't repeat. So this is a warning, not a suggestion. So even if we are just a few of us here, how do you choose which features to implement in your projects? Do you have a backlog? Anyone? Or do you have a product manager that tells you what to do? What's the next things to implement? Do you do by subterfuge? Do you sneak your favorite feature inside the next release without anyone looking? Choosing which feature to be it's a primary part of our job. You usually look at the best of class in your market and try to do things better and faster. Or maybe you're making something that there's a common understanding of how it should look and how it should feel, and you are trying to do it cheaper and easier to use. Or maybe you are having a chat with your users and get back to the office with a list of desiderata, hopefully a sensible list of desiderata, and a reasonable time frame. So sometimes, however, you get to build something completely new, and you have to decide what goes in and what doesn't. Some time ago, in 1958, the problem was exactly this. Industry and academia were starting to realize that this computer thing was becoming big. But there was a big problem. No university could start a programming course because every institute has its own school of thought, its own homegrown tools that no one else had. Every commercial industrial language, Fortran, COBOL, and a few others, was so tightly integrated with each model and sometimes each single machine that the skills that you gain on one implementation weren't transferable to another. And scientific work was very hard to communicate and to reproduce. These ideas were well known on both sides of the Atlantic. In particular, the GAM, Gesellschaft für angewandte Mathematik und Mechanik, and its US counterpart, the ACM, the Association for Computer Machinery, started pushing an initiative to design a new common language. Their representatives met in Zurich in late May, and yes, that's exactly 66 years ago. And they started working on IAL, International Algebraic Language. However, they quickly realized that this name sucked, and they chose ALGOL, way cooler, Algorithmic Language. They shared a few objectives: to be as close as possible to the standard mathematical notation so that code could be readable with little explanation. It should be usable to describe numerical processes and publication as a means of communication between interested parties. It should be readily translatable to machine code, that is, with a program by the machine itself, regardless of the architecture. That is, compilable by a compiler program and portable between different computers. They had some great results. They had a first standard, ALGOL 58, and that got published and got immediate interest in journals and related publications. The overall result of the conference became the Zurich report that contained all the features that have been selected and implemented. But soon there were remarks, observation, and so Peter now started collecting the ALGOL bulletin and started circulating it among the conference participants to coordinate the exchange of opinions, the issues, corrections to the standard, and so on. And there was a lot of things to discuss because, of course, you never get right the first time. So there were discussion about specific features, the discussion about overall objective and perspectives, and so on. Among others, a topic of heated discussion was recursion. Was recursion necessary? Was it feasible? No other language at the time had it. Yeah, John McCarthy was involved in the ALGOL committee, but his Lisp language was little more than a personal experiment at the time. For some participants, however, recursion was a necessity. To implement many mathematical expressions, recursion is instrumental to keeping the notation as close as possible to the original math. However, for others, it was an inefficient luxury. In a world where memory is still measured in kilobytes and programs are translated in fixed points of the RAM of each computer, recursion was too dynamic, too new, too experimental to implement. With all these things to discuss, a new conference was needed. And so we arrived at January 1960 in Paris for the ALGOL 60 conference. Here, lots of things happened. Peter now arrived with a draft standard that he compiled from the ALGOL bulletin. But some of the conference members were, well, not pleased of how he took the material in his own hands. In particular, F.L. Bauer said later he had not been commissioned to do so. It was a fait accompli. Nevertheless, the conference started working on that draft and started working with a very tight schedule of only 5 days, from the 11th to the 16th. A lot of features were decided in those days, clarifications from the previous standards, a new discussion, things like that. For example, the exact semantics of arithmetic expressions, the for statement in a form that set the template for all the following languages. Code blocks and procedures were defined in those days, and they were more or less just like those that we use now to organize our code. However, recursion didn't make it. Now reports by a narrow margin. So, the standard is decided, the conference is over. Peter now gathers all the papers and starts collecting the ideas to write down the definitive standard. ALGOL 60, however, was an instant success. Even before now had started summarizing and typesetting the final standard, papers from the conference members were starting to appear in journals with algorithms, with proposals, with methods using the new language. But someone was not happy. In Amsterdam, Adrian van Wijngaarden and his fresh from PhD student Edgar White Dijkstra placed a phone call to Peter now and told him, you know, we think we found a fundamental issue with the standard, but we think we can solve it with a simple addition. In section 5.4, you just need to add any other occurrence of the procedure identifier within the procedure body denotes activation of the procedure. So Peter now, I think you all imagine, would have responded, well, the standard is closed. I can change it. Instead, he said, I got charmed with the boldness and simplicity of this suggestion, and decided to follow it in spite of the risk of subsequent trouble over the question. And so, he changed the approved standard and inserted this small change. Of course, this change added recursion to the ALGOL 60 language. You know what happens with small changes? No one notices them until it's too late. No one saw the small new phrase until the standard was just were already printed and started circulating. And the first implementers were getting back with feedbacks from the first implementations. And so ALGOL 60 came out with everything that became common understanding that a language should have. Arithmetic expressions, iterative and conditional statements, blocks and procedures to organize code, and recursion. Almost 20 years later, Peter now writes a paper about the story of the development of ALGOL 60. And so he had to write 27 pages of paper, and then he had to add 13 pages of comments and remarks by the other committee members. When your comments are half as long as your text, you know that some discussion is going on. In fact, we have F.L. Bauer that called the phone call episode the Amsterdam Plot on introducing recursivity. Even later, Dijkstra admitted its inclusion was almost an accident, certainly a coup. However, that inclusion, that small change, was extremely influential. Dijkstra again says that it was crucial to get, for example, Tony Hoare able to write quicksort, because at the time he had the idea, he had everything in his mind, but he had not the tool to write that algorithm. When he saw ALGOL 60 and he saw the recursion feature, he could immediately write down quicksort and started all the work on advanced algorithms. So, what more can we get from this story? Yes, this time we were lucky. However, people do people things. Your team is made of people. Do they share your goals? Do you share theirs? Have you asked them? Sometimes ego, individualism, hubris get in the way of what the team should do. And please, be a teammate, not a Dijkstra. If you don't agree with the choices your team is making, speak up and try to find a common ground. You might be right, but you may also be wrong. You may be missing some piece of context. And that's why software works if people talk to each other. My friend and ex-colleague Luca Del Pupo said this, and it's a too good and appropriate to let it pass. Don't plot, talk, and make your software work. Thank you. These are my sources. And as a post-credit bonus, if you look up this article, this very recent article, you'll get some through introduction in recursive procedures, and you get to know that maybe the small change of the Amsterdam plot wasn't even necessary, because ALGOL couldn't prohibit recursive activation. And that's the real end. Thank you.